Hi, all. Just a quick review of what we did last week, that the couple days before Thanksgiving. Here's just some of our slides. These are posted on our classroom calendar, so you can check them out, but I just want to give you a quick overview. Basically, first thing we did is review how to do a claim evidence reason writing assignment, because that will be on your summative test. And so the claim part is basically answering the question, right? What happened? Evidence. Again, this outlines what you need to be including. It kind of depends on your data, but generally at least 2 pieces of evidence. And then reason would be the scientific explanation. And so in the slides, you can see I made kind of an example using the sunscreen lab of what a good claim evidence reasoning would be. So that would be a good thing to read through. Then we did a little PhET simulation, and you can look that up under solubility and conductivity, PhET, P-H-E-T. And we just looked at, what was going on at the molecular level in salt versus sugar and how that affects conductivity. So salt would be a good conductor, or ionic compounds would be good conductors in water versus molecules like sugar that would not be. So you can explore that. And then our lab, we introduced our lab and this idea of, okay, if we have an unknown substance and we're testing it, we could kind of potentially identify what kind of bonding is in that substance based on its properties. And so the properties we looked at are here in the lab. I'll go ahead and switch to that tab here for our lab. So these were all of the substances we investigated in the lab, and we looked at melting point, solubility in water, and conductivity in water. And then we used that to see if we could find a pattern and then make a prediction about what this unknown substance might be, what kind of bonds it might have. So our choices are ionic compound, polar covalent compound, or non-polar covalent compound. And so we could test it in the lab and we could see which properties it matched up to. That was our goal. And there's some sentence frames and things, but that's ultimately we're going to have to write about on the test. So you'll be given a list of substances and their properties in terms of melting point, conductivity, and solubility, and then asked to make a prediction about what that unknown is. Is it a polar covalent? Is it non-polar? Or is it ionic? What kind of properties you might expect for it to have. So just as a quick overview, one of the things we talked about is we kind of went through these lists and we identified them as ionic, polar, or non-polar. And so, of course we know for ionic compounds, that's when we have a metal and a non-metal. So our ionic compounds we can identify as this one, potassium chloride. This potassium is a metal. We can say, oh, this sodium bicarbonate, the sodium is a metal, so that could be ionic. Potassium bitartrate. I see a K there, that's a potassium, that's a metal, so that's going to be ionic. Sodium chloride, NaCl, that's Na is a metal, so that would be ionic. Paper clips were kind of a weird one. We won't need to get into that if you weren't here. But in terms of polar and non-polar, then when we're looking at these substances, a lot of them we can see there's carbons and hydrogens and oxygens, carbons and hydrogens and oxygens. And so it gets a little bit more complicated. Basically, if we look at our polarity between our carbon and our hydrogen bond, we know that that's non-polar because that's a difference in electronegativity of just 0.4. Carbon is 2.5 electronegativity, hydrogen is 2.1, so there's just a difference of 0.4. So paraffin is clearly non-polar. But then we start looking at some of these other ones and we're thinking, okay, well, we know oxygen is polar. It makes something polar. It makes something have a dipole because it's very, very electronegative. But some of these act like nonpolar molecules. And the reason is because you have to look at how many oxygens there are for the size of the molecule. So, for example, lard we know is a fat, right? It's like this animal fat and it behaves like a nonpolar substance. It doesn't mix with water. It's not a good conductor of electricity. It's got a very, very low melting point. And so then we look and we say, well, this one has 21 carbons, but only 5 oxygens. So relative to the size of the molecule, it's not very polar because there aren't very many oxygen relative to the size of the molecule, because there's 21 carbons. That makes it a very long, big molecule. But if we look down here, we look at sugar, sucrose, it has 11 oxygens to 12 carbons. So compared to the number of carbons or the size of the molecules, there's relatively a lot of oxygens there. And so we would say sucrose is polar, a polar molecule, because there's so many oxygens. Xanthan gum, we'll look at that, and again we see that kind of ratio of 35 carbons to 29 oxygens. We would say that's polar because it's a lot of oxygens for the size. But if we look over here, like coconut oil, again, coconut oil, we're like, that's going to behave like a non-polar molecule. A non-polar molecule has a low melting point and low conductivity, and we see it's 2 oxygens for 12 carbons. So we're going to say that's non-polar because there aren't very many oxygens in relation to the carbon. So we just want to point that out and go ahead and review like the procedure and what happened there. And then we're also looking at the properties we expect for ionic versus polar versus non-polar. But we're going to review that again today in class. And we did that on Wednesday. So we should be able to kind of know and say like, oh, if something's ionic, it's going to have a very high melting point. It's going to be a very good conductor of electricity. It's going to be a very good, it's very soluble in water. And then non-polar is going to be the opposite of that. Non-polar behaves very differently because there aren't any charges really on that molecule. So it's going to have a low melting point. It's going to be low solubility, low conductivity. And then polar molecules are in the middle, right? They've got a bit of a charge, but not as much as ionic. So they end up having properties sort of in the middle where it's like they're pretty good conductors. They're pretty soluble. They have a medium melting point. Okay, so that was the big gist of the lab. We're not turning in that lab for a grade. Basically, we're going to take the quiz and do our claim evidence reason based on what we learned in the lab. And that's kind of how we're going to assess and see how we're doing. And then we'll be, again, obviously seeing that again on our summative, on our test.